Hey guys, good evening, good evening, good evening, and welcome back again to your Unacademy NEET English channel. I hope all of you are doing great. Can you quickly let me know in the chats if all of you can hear me, if I'm perfectly audible, visible to everyone? Can you let me know quickly in the chats, people? Everyone in the chats. Can you quickly let me know in the chats, people? Chemical bonding part 2 will be posted exactly at 4 p.m., okay? Chemical bonding part 2 will be exactly posted at 4 p.m. So can you all hear me? If I'm perfectly audible, visible to everyone, just let me know quickly in the chats, people. Just quickly let me know in the chats. All right, so today we are going to do the questions, I would say the top 100 questions of the chapter chemical bonding. It includes the questions of your NCERT, right? Whatever questions are given in NCERT exercise, right? Whatever questions have been asked in NEET examination, whatever questions have been asked in the JEE Mains examination from this particular chapter, I'll be doing all those questions with you in this particular session. Yeah? Right? All right, so should we start then? And I would want whatever questions I'll be doing here, whatever questions I'll be giving you here, first of all, I would want their answers in the chat section of this particular video. Okay? I would want you guys to write the answers in the chats continuously. So I want you guys to be very active in the today's session because it's going to be a question practice session of the chapter chemical bonding, right? And my dear students, you are going to let me know the answers of all the questions in the chats. So be active in the chats today. Yes? So let's start the session with the question, my dear students, which is on your screen. Look at the question. The question has been asked in AIPMT 2000, when you were not even born. Among the following, the electron deficient compound is. I want the answer from all of you. It's a simple basic question, and I believe everyone can easily solve it. Tell me, among all these options, which one is the electron deficient compound? Everyone, people, in the chats. I am looking at your chats only. A simple and basic question with which I'm starting the session, right? This is going to be the confidence booster for all of you. I believe so. Absolutely, my dear students. The electron deficient compound among all of these is going to be which one? It's going to be your BCl3, right? It's going to be your BCl3. As you can see, this boron, it's making 3 bonds with chlorine, right? Okay, so 2, 4, 6. It has got 6 electrons in its valence shell. So it should have 8, but it has only got 6. So definitely this particular compound is your electron deficient compound over here. Okay? A simple and basic question this was, which I believe everyone has already solved. Look at this particular question. The question has been asked twice, 2013 as well as 2005. The correct sequence of increasing covalent character. Increasing covalent character. Yesterday only I've taught you this. The question based on Fajan's rules. The question based on Fajan's rules. I want the answers from everyone. The question which is based on Fajan's rules. Everybody, people. The correct sequence of increasing covalent order. What do you think will be the answer of this question? Quickly. My dear students, first of all, if you look at all these compounds, LiCl, NaCl, and BCl2, this is basically Li positive, this is Cl negative, right? This is Na positive, this is Cl negative. This is beryllium di positive, this is Cl negative. Correct? Okay, simple till here. Now you tell me, is the anion same everywhere? Yes, it is Cl negative. Okay. I'm not going to talk about Cl negative because it's same everywhere. So I'm going to decide as per the cation, Li positive, Na positive, Be di positive, right? Now, you know, polarizing power of the cation is directly proportional to the charge on cation. So where is the charge on cation more? Charge on cation is more on beryllium. More the charge on cation, more the polarizing power of cation. And if more the polarizing power of cation, more is going to be the covalent character. So I would say BCl2 will definitely have maximum covalent character. Followed by. Now, among Li positive and Na positive, since both have got equal charge on them, now you'll be deciding as per size. And you know, polarizing power is inversely proportional to size. Lesser the size, more the polarizing power. More the polarizing power, more the covalent character. So it's going to be LiCl, and at the end, it's going to be NaCl. This is the order of covalent character which I was supposed to give, right? Now you can find the options. NaCl, LiCl, and BCl2. Perfect, guys. Is this particular question clear to everyone? Is this particular question clear to everyone? So it's going to be option C. That is going to be the correct answer of this particular question. I believe this sort of a question you can easily solve from now onwards if it comes. Okay, look at this one. The question has been asked in JEE Mains 2022. Can you give this question a try? Arrange the following in increasing order of their covalent character. Again, I have to arrange these compounds on the basis of their covalent character. Again, the question which is based on Fajan's rule. And I believe you can easily solve this one too. Just give it a try. I just want to see first of all what you are going to write in this question. I just want to see first of all, what do you think about this particular question? Quickly. You should be able to solve this one. You should be able to solve this particular question, guys. It's a simple one. It's not difficult or something. Anish, there is some technical glitch in HSP sir's profile. I don't know what's exactly happening, right? Let's see. Let's wait for 1-2 days more. I think it'll get fixed. Well, I can see majority is coming up with option 2. So let's exactly see what will be the correct option of this particular question. Guys, this is again a simple question. As you can see, this is basically calcium di positive, F negative. This is calcium di positive, Cl negative. This is calcium di positive, Br negative. This is calcium di positive and I negative. So I'm not going to talk in terms of calcium here because it's same everywhere. Okay. Now, F negative, Cl negative, Br negative, I negative. The charge on every anion is same. If the charge on every anion is same, we are going to decide as per the size. You're going to decide as per the size, right? Now, which anion has got maximum size among all? F negative, Br negative, Cl negative, or I negative? I negative has got maximum size. More the size of anion, more is the polarizability of anion. And if more is the polarizability of anion, more is going to be the covalent character, right? So I think I was supposed to give the covalent character. So it's going to be option D, which will be having maximum covalent character, right? Followed by option C, followed by option B, and followed by option A. So this is the increasing order of covalent character which I was supposed to give. Correct? So what is the correct answer then? It's A, B, C, D only. Right? Perfect. I believe this is clear. Moving on to the next question, guys. Moving on to the next question. This question has been again asked in your JEE Mains 2022. Check it out and let me know its answer. Check it out, people, and let me know its answer quickly. Everyone. The question is arrange the following in the decreasing order of their covalent character. Again, the similar sort of question, right? So the frequency of these questions is too much basically when it comes to your examinations. And the questions are basic and simple based on your Fajan's rules. So if you look at this particular question, this is basically Li positive and Cl negative. Na positive, Cl negative. K positive, Cl negative. Cs positive, Cl negative. So this Cl negative, everywhere it's same, right? Now the charge on every cation here is same. The charge on every cation here is same. So we are going to talk in terms of size. So we have got Li positive, we have got Na positive, we have got K positive, we have got cesium positive. Perfect. Down the group, size of the cations will increase, right? And you know, if size increases, what happens to polarizing power? Polarizing power of cation decreases. And if polarizing power of cation decreases, covalent character is automatically going to decrease. So which one will be having the least covalent character? Least covalent character will be shown by CsCl, right? So D will show the least covalent character. D will show the least covalent character, right? D will show the least covalent character. And after D, it's going to be your C. After D, it's going to be your C, right? After C, it's going to be your B. And after B, it's going to be your A. So this is the correct option of the question. So it's supposed to be option 3, right? Am I clear to everyone? Simple question again. Simple question again this was. Look at this one. The question has been asked in your JEE Mains 2021. Check it out. Check it out, people. Assertion. Lithium halides are somewhat covalent in nature. Lithium halides are somewhat covalent in nature. Because of the smaller size of lithium. Absolutely, its halides will be somewhat covalent in nature. So it's a correct statement, right? So lithium possesses high polarization capability. Absolutely, the reason is also correct. Because of the smaller size of lithium, lithium possesses high polarizing power, due to which its halides will be covalent, right? So assertion is right. Assertion is right. Reason is right. And at the same time, reason is the correct explanation of assertion. So it has to be option 4. That will be the correct answer of the question. Perfect. Again, a simple basic question this was, and I believe you easily solved this one. Okay. The question which was asked in your NEET 2020. What is the correct order of decreasing ionic character? What is the correct order of decreasing ionic character? You should know ionic character is basically inversely proportional to covalent character. This is something which all of you would know. So let us give the order of covalent character first and then reverse it. We'll get the order of ionic character. Yes? Check it out quick. Check it out quick, guys. What do you think is the correct answer? If you look at the question carefully, this is basically Pb di positive and Cl negative. This is Pb di positive, F negative. This is Pb di positive, I negative. And this is Pb di positive, Br negative. So this is everywhere the same. So I cannot decide on the basis of Pb here. I will have to decide as per the anion Cl negative, F negative, I negative, and Br negative. Right? Now the charge on every anion is same. Charge on every anion is same. So we are going to decide as per the size. We are going to decide as per the size of the anion. So which anion has the maximum size? I'll say I negative will have maximum size, right? I negative will have maximum size. So if I talk about the covalent character, if I negative has got maximum size, its polarizability is maximum. More the polarizability of anion, more is the covalent character. So 3 will have maximum covalent character. 3 will have maximum covalent character followed by your fourth, followed by the first one, and then comes your second one. This is the decreasing order of what? This is the decreasing order of covalent character, right? This is the decreasing order of covalent character. Now, what about the ionic character? Ionic character is going to follow the same order, but in the reverse way. This is the increasing order of ionic character. But do I have to write the increasing order of ionic character or decreasing? I have to write the decreasing order of ionic character. This is the increasing one. So just reverse it. You will get the decreasing one. Perfect. Again, a simple basic question, which I believe you could easily solve. Right? Okay. Look at this one. Again, the question based on the same concept. Select the most ionic. Select the most ionic. Most ionic means least covalent. Most ionic means least covalent. Basically, we are supposed to select the least covalent and most covalent. Least covalent and most covalent here. First one should be least covalent. Second one should be most covalent. Now, guys, if I straight away look at option number 2. This is Pb di positive. This is O di negative. This is Mn. Mn will be here in +7 oxidation state. Oxygen will be -2 oxidation state. Okay, I think you got the answer already. Is that? See, if you talk about this Mn2O7, here Mn is in +7 oxidation state, right? It is +7. More the charge on cation, more will be its polarizing power. More is the covalent character. So this is more covalent. This is more covalent. So technically this will be less covalent because the charge on cation is less, right? Well, if you check all the other options as well, this is chromium here in +6 oxidation state, manganese here in +7 oxidation state, chromium here in +6 oxidation state, iron here is in +3, right? Chromium in +6 and Sn is going to be in +4 oxidation state, right? So there's only one option that is perfectly fitting. What is that? That is option number 2. I hope this is also clear to everyone. Now, again, the similar sort of question. At least this question everyone has to answer in the chats. This question everyone has to answer in the chats, people. Yeah. Check it out. Again, you have to give the answer as per the increasing covalent character. This sort of a question you should be able to solve easily. And it's a similar question, guys. Pretty simple. See, first of all, if you look carefully, this is Na positive, Cl negative, Rb positive, Cl negative, Mg di positive, Cl negative, Al tri positive, Cl negative, right? So Cl negative everywhere is same. Now check your cation basically. More the charge on cation, more will be its polarizing power, and more the polarizing power of cation, more is the covalent character, right? I have to select the increasing order. So 4 will have maximum covalent character. Followed by your third one, right? Now, among NaCl and RbCl, NaCl will have more. I think I wrote the reverse order. So basically 4 is your maximum covalent, followed by third. Now, third. Now, among NaCl and RbCl, first one will have more covalent character than that of your second one. Do you see any option like this? 2, 1, 3, 4. 2, 1, 3, 4. This is the order, increasing order of the covalent character. Right? Now, look at this question. The question was asked in your NEET 2020. Check it out, people. Check it out. Tell me its answer. Which of the following set of molecules will have zero dipole moment? Which of the following set of molecules have got zero dipole moment? Quickly. Zero dipole moment. Quickly, guys, everyone. Which of the following set of molecules have got zero dipole moment? If you look at option number 3, the first compound which you have, that is boron trifluoride. This is BF3. And my dear students, if you look at BF3 properly, first of all, if you look at this particular bond between boron and fluorine, right? Fluorine is more electronegative, boron is less electronegative, and the direction of dipole moment is from less electronegative to more, less electronegative to more. Perfect. Now, these two moments are at an angle of 120. So the resultant will be in this direction, right? So this resultant and this one, they get cancelled out. So I would say its net dipole moment here is 0. Number 1. Number 2, you have got BeF2, beryllium difluoride, right? This is your BeF2. This is how your BeF2 looks like. Less electronegative to more electronegative. Cancels each other. So net dipole moment here again is 0, right? Then you have got carbon dioxide. Carbon dioxide structure, I believe everyone already would be knowing, right? Less electronegative to more, cancels each other. So net dipole moment again here is 0, right? Then we have got 1,4-dichlorobenzene. This is your 1,4-dichlorobenzene. Less electronegative to more electronegative. Less to more, cancels each other. So net dipole moment again here will be 0. So I would say this is basically the set of the molecules wherein the net dipole moment of all the molecules is basically 0. I believe this particular question is again clear to everyone. Yeah. Now, my dear students, talk about this particular question. The question was asked in your NEET 2019. Check it out. NEET 2019. Check this question out quickly. Tell me the answer of this particular question, everyone. Everyone in the chats. Everyone in the chats. Which of the following is the correct order of dipole moment? Quickly. First of all, more the electronegativity difference between the atoms. More the electronegativity difference between the atoms, more is going to be the dipole moment. This is the first thing which you should know. More the electronegativity difference between the atoms, more is going to be the dipole moment. Right? Now, as far as I can see the options, the electronegativity difference between oxygen and hydrogen will be maximum. The electronegativity difference between oxygen and hydrogen will be maximum. So water will have maximum dipole moment among all. Water will have maximum dipole moment among all. So this is clear. Now, among NF3 and NH3, if you make NF3 over here, look at this NF3 molecule. This is nitrogen having a lone pair. And similarly, if I make NH3 molecule here, again nitrogen has got the lone pair, right? Now, which one has got more dipole moment? Let's check it out. Since the direction of bond moment is from less electronegative to more electronegative, right? Less electronegative to more electronegative, less to more, and the moment due to lone pair is towards the lone pair, right? The moment due to lone pair is towards the lone pair. Similarly, due to this bond, less electronegative to more electronegative, less to more, less to more. Now you think, see, these are all the vectors. These are all the vectors which I'm showing. Now tell me, think over it, where will be the resultant maximum? And I say in this particular one, there will be some cancellations as well. There will be some cancellations as well between the vectors, right? But here, as you can see, all are pointing in the same direction. So net dipole moment of NH3 will be definitely more than that of NF3. So NH3 will have more dipole moment than NF3. And BF3, few minutes back only we saw, BF3 has got 0 dipole moment. So it's option number C. That's going to be the correct answer of this particular question. I hope you can easily solve this sort of a question as well if it comes. Tell me the answer of this one. NEET 2018. What do you think about this one? NEET 2018. Which of the following is the correct order of dipole moment? Which of the following is the correct order of dipole moment? I think the question is different. The question is which of the following will have 0 dipole moment? Which of the following halides maybe will have 0 dipole moment? I think that should be the question. Right? So basically, let me first of all check the question carefully. The question should be different here. Which of the following is the correct order of dipole moment? But what correct order? Molecule should be given to us, right? Molecule should be given to us. I think this question will be related to some BF3 only. The question will be related to some BF3 only, right? Which will have 0 dipole moment. I think that would be the question. Anyways, the question is not complete here. So anyways, I'll go with boron. Yes, in the actual question, there should have been BF3 given, wherein you were supposed to check which of the following has 0 dipole moment. So it should be BF3 only. All right, look at this one. Which of the following is a polar molecule, right? Which of the following is a polar molecule? What is the criteria for the molecule to be polar? The net dipole moment of the molecule should be non-zero. If the net dipole moment of the molecule is non-zero, we say the molecule is polar. We call the molecule as polar. And if the net dipole moment of the molecule is 0, we call the molecule as non-polar. We have to check which of the following is a polar molecule. So net dipole moment should be 0. Net dipole moment should be 0, right? Now, my dear students, first of all, I'm giving you some molecules over here, right? First of all, whenever you see of the molecule AB2L0, whenever you see of the molecule AB3L0, whenever you see molecule of the type AB4L0, similarly AB5L0, similarly AB6L0, similarly AB7L0, similarly you have got, for example, AB2L3, or you have got AB4L2. Whenever you see these molecules, whenever you see these molecules which are of these types, remember their net dipole moment directly you'll be taking as 0. Their net dipole moment directly you'll be taking as 0, and those molecules are basically non-polar in nature. Perfect. Now, if I check the types of these molecules, first of all, how do we check the types? That is important. For example, SF4. If you talk about sulfur has got how many valence electrons? 6. How many surrounding atoms are there? 4. That means there are 4 sigma bonds. Now, out of 6 valence electrons, which sulfur had, 4 have been utilized to form 4 sigma bonds. So there'll be 2 electrons left as such on sulfur in the form of a lone pair, right? So 4 sigma bonds, 1 lone pair. So type of this molecule is AB4L1. Now, is this AB4L1 coming in this particular category? No, right? So it is supposed to be polar in nature. I think rest all the molecules will be coming under this particular category, right? Yes? Right, people? Okay, so it's going to be option 1 directly, which is going to be the correct answer. So this is going to be the polar molecule. If you look at this one, SiF4, for example. Tell me how many valence electrons we have here for silicon. Silicon comes in carbon family, which has got 4 valence electrons. How many surrounding atoms? 4. So there are 4 sigma bonds. 4 valence electrons, 4 sigma bonds. So silicon has utilized all the 4 valence electrons to form 4 sigma bonds. So there'll be no lone pair on silicon. If there is no lone pair on silicon, the type of the molecule will be AB4L0. And AB4L0 is coming here. That means this molecule is supposed to be non-polar. Similarly, you can check the rest. So the answer of this particular question is going to be option 1. Yeah? I believe this is clear to everyone. And if this is clear to everyone, let's move on to the next one. This particular question, right now only, few minutes back only we solved. Yeah? Few minutes back only we solved this particular question. Why NH3 has got more dipole moment than NF3? This is something which we discussed few minutes back only. Okay? Among BF2, BF3, H2O, NH3, CCl4, HCl, the number of molecules with non-zero dipole moment. Check it out and let me know quickly. The number of molecules with non-zero dipole moment. Again, this sort of a question you should be in a position to solve. If you talk about BF2, just check the type of the molecule. If I talk about the type of the molecule, it's going to be AB2L0. Similarly, you have got BF3. What is the type of the molecule? When you check it out, it will be AB3L0. For example, you have got water. What would be its type? It's going to be AB2L2 type. Okay. And if I talk about NH3, NH3 comes in which type? It comes under AB3L1 type. If you talk about CCl4, CCl4 comes in AB4L0 type. Right? Then you have got HCl. HCl already, you know, it's polar directly. It is polar, right? It has got dipole moment. Now, I have to check among the following the number of molecules with non-zero dipole moment. AB2L0 non-zero, AB3L0 non-zero, right? Which one? AB4L0 non-zero. Perfect. So, non-zero dipole moment. So, the answer of this particular question is going to be 3. Correct? Non-zero. Sorry, I did the reverse. This is the molecule which will be having 0 dipole moment, right? Because it's of AB2L0. This is the molecule again whose dipole moment is 0, right? This is the molecule whose dipole moment is 0. Perfect. This is non-zero. This will be non-zero. This will be non-zero. So again, the answer is going to be 3 only, right? Answer is going to be 3 only. 3 polar, 3 non-polar. Check this one out. The question has been again asked in your JEE Mains 2023. Statement two statements are given basically. Dipole moment is a vector quantity, which is correct. And by convention, it is depicted by a small arrow with a tail on the negative center and head towards the positive center. Is that correct? Is that correct? Is that correct? Quickly. Depicted by the small arrow with the tail on the negative center and head on the positive center. Is the statement correct, guys? Tell me quickly. In chemistry, the direction of dipole moment is taken from positive to negative. The direction of dipole moment is taken from positive to negative. So tail is on positive center and this arrow is on negative center. Or we say it's from less electronegative element to more electronegative element. Less electronegative element to more electronegative element. So statement 1 is incorrect. It is incorrect. The crossed arrow of the dipole moment symbolizes the direction of shift of charge in the molecule. Is this correct? Tell me, what is the answer of this question now? Is it simple? It is simple. If I talk about both the statements are basically, if we talk about statement number 1, that is incorrect. Statement number 2, that is your correct one. Because this direction of arrow, what it indicates? What it indicates? For example, you have got HCl molecule. You have got HCl molecule. Chlorine is more electronegative. So it will take the electron pair towards itself. So delta negative. This is delta positive. And the direction of this moment will be from positive to negative. This arrow indicates basically the shifting of electron pair. The arrow indicates the shifting of electron pair here. I hope this sort of a question you can easily solve. Okay. Even this sort of a question was asked in your 2020 JEE Mains. You can check it out. Tell me its answer. Decreasing order of dipole moment in CHCl3, CCl4, CH4. Now, first of all, if I talk about CCl4 and CH4, both these have got AB4L0 type. This one is also AB4L0. So their dipole moments are equal and both are equal to 0. Their dipole moments are equal and both are equal to 0. CHCl3, it will have some dipole moment. It will have some dipole moment. So CHCl3 will have maximum dipole moment, and these two have got equal dipole moments and both are equal to 0. Right? So it's directly option 1. That will be the correct answer of this particular question. No need to think a lot about this one. Which of the following possesses the dipole moment? Among all, which of the following will possess the dipole moment? Again, check the type of the molecule and decide. Check the type of the molecule. If I talk about SF6, SF6 type is AB6L0, right? SO2 will be AB2L1, right? AB2L1. H2S will be AB2L2. SF4 will be AB4L1. Now we have to check which of the following possesses dipole moment. See, this is not going to possess any dipole moment. Net dipole moment here is 0, right? All the others, AB2L1, AB2L2, AB4L1, they are going to possess the dipole moment, right? So it's going to be B, C, and D. B, C, and D is the correct answer. They are going to possess the dipole moments. Okay? Look at this one, guys. AIPMT 2015. And again, this is a question which you should be in a position to solve. Again, this is the question which you should be in a position to solve. Too easily. Check it out and let me know quickly. Check it out and let me know quickly, guys. Quickly, let me know in the chats, everyone. People are saying option 4. Is that correct order of bond energy? Which one requires more bond energy? Which one requires more bond energy? If I look at the options, I can see one option is directly evident. It is F2 and Cl2. F2 and Cl2. F2 and Cl2. F2 has got lesser bond energy. Since this fluorine has got 3 lone pairs, this fluorine also has 3 lone pairs. Even chlorine has 3 lone pairs. Every chlorine here also has 3 lone pairs. But the size of fluorine is less. If the size is less, there will be more repulsions between the lone pairs. If there are more repulsions, definitely the bond energies will be less. F2 will definitely have lesser bond energy than that of Cl2. Correct? This is the correct option. This is the correct option. Okay, tell me about this one. Which of the following molecule contains no pi bond? At least this question everyone has to solve. Which of the following contains no pi bond? No pi bond. Guys, you already know the structure of water. There is nothing to think here. You already know the structure of water. Perfect. Do you see any pi bond in water? There is no pi bond in water, right? So your direct answer has to be water. In all the other cases, carbon dioxide, NO2, SO2, there will be pi bonds. There will be pi bonds. Tell me the answer of this particular question. The correct order of OO bond. The correct order of OO bond. Now, I don't know whether they have given the bond length or bond order. We don't exactly know whether they... I think they would have given the bond length only. We have to talk about the OO bond length. We have to talk about the OO bond length. Right? Quick. What should be the order? First of all, if you talk about O2, O2 is a 16 electron species. And 16 electron species have got the bond order 2, right? If you talk about this H2O2, H2O2 basically is, you can write it as O2 dinegative. O2 dinegative means 8 into 16, 18 electron species. O2 dinegative is 18 electron species. 18 electron species have got the bond order of 1, right? And in case of ozone, due to resonance, there will be partial double bond character. In case of ozone, there will be partial double bond character. So bond order in case of ozone will be between 1 and 2. Between 1 and 2. Now you should know bond length is inversely proportional to bond order. Perfect. Lesser the bond order, more is going to be the bond length. So first of all, which one has got the least bond order? It's going to be H2O2 has got the least bond order, so maximum bond length. So H2O2 comes first, right? And at the end, O2 has got the maximum bond order among all, so it will be having least bond length. So which one will come after that? It's going to be ozone. So this is going to be the bond length order. This is going to be the bond length order. I believe this is clear. Because your bond length is inversely proportional to bond order, right? So it's H2O2, O3, then O2. Tell me the answer of this question. Again, a simple question this is. Quickly, guys. Quickly, tell me the answer in the chats. Quick. I can see majority is coming up with option D. Absolutely, it has to be option D only. So in case of Cl2 molecule, you know chlorine has got 3p5 configuration. This also has got 3p5 configuration, right? So 1, 2, 3, 4, 5. Even this chlorine has got 3p5 configuration. 1, 2, 3, 4, 5. Let this be Pz, let this be Px, let this be Py. Let this be Pz, let this be Px, let this be Py, right? So this Pz and this Pz. Let's say this is your Pz atomic orbital of one chlorine. This is one more Pz of, this is one Pz of one more chlorine here. They are going to do the add-on overlapping and they will lead to the formation of sigma bond here, right? So this is basically your pp overlapping happening in case of Cl, in case of Cl2. In case of Cl2, correct? Tell me the answer of this particular question. Which of the following orbitals, which of the following represents the zero overlap? Where do you see the zero overlap exactly? See, over here, positive, positive. This is the positive overlap happening. This is first of all the head-on overlap. And at the same time, same sign on same side means positive overlap, right? The overlap is happening here. This is the negative overlap, positive, negative. Opposite sign on same side, this is negative overlap. We have to check the zero overlap. We have to check the zero overlap, right? We have to check the zero overlap. Zero overlap is happening here. There is no overlap here, right? This is the case of the zero overlap. Perfect. If they would have asked, which of the following shows positive overlap? Positive overlap means first one, because same sign on same side. If they would have asked negative overlap, opposite sign on same side, then this was the negative overlap. Tell me the answer of this one. What is the correct order of bond energy of single bond, double bond, triple bond? This is something which everyone of you would be knowing. This is a triple bond, double bond, single bond. Triple bond means more force of attraction between the atoms. More energy is required to break it, right? So it's going to be C triple bond. C will have maximum bond energy, right? Maximum bond energy followed by C double bond C followed by C single bonds. More the bonds, more the force of attraction, right? Simple. the total number of pi bond electrons. The total number of pi bond electrons. They're not asking you about the pi bonds. They're asking you about the pi bond electrons, right? So first of all, check how many pi bonds do you see? 1, 2, 3, 4. 4 pi bonds. 4 pi bonds means 8 pi electrons. So there are 8 pi electrons in this particular molecule, which is given to us. Simple and basic. Okay. Tell me, the molecule not having the pi bond. See, I believe you already know the structures of all of these. See, if you talk about O2, there's a double bond between two oxygen atoms. N2, there's a triple bond, right? Carbon dioxide, this is C double bond O double bond O. Cl2 molecule is the only molecule where there is no pi bond, right? It's a single bond. So I was supposed to check the molecule not having pi bond. So it's going to be Cl2, which is not going to have any sort of pi bond. Okay. Discuss the shape of the following molecules using VSEPR theory. Now, these sort of questions are frequently asked. These sort of questions are frequently asked. If you look at all these questions, see guys, how do we check it? This is your BCl2, right? BCl2, one by one we are going to talk about so that you'll understand it properly in a better way. This beryllium, how many valence electrons it has? It has 2 valence electrons. How many surrounding atoms it has? 2 surrounding atoms. 2 surrounding atoms means 2 sigma bonds. Number of surrounding atoms is equal to the number of sigma bonds. Since beryllium had 2 valence electrons and it has utilized both the valence electrons to form 2 sigma bonds, so there'll be no lone pair on beryllium. If there is no lone pair on the beryllium, the type of the molecule will be AB2L0. And AB2L0, what would be its shape? AB2L0 is always linear in shape. So this is linear, number 1. Number 2, BCl3. Number 2, BCl3. Boron. How many valence electrons boron has? 3. How many surrounding atoms do you see? 3. Number of surrounding atoms is equal to number of sigma bonds. So 3 valence electrons, 3 sigma bonds. That means there is no lone pair on boron. If there is no lone pair on the boron, the type of the molecule will be AB3L0. If the type of the molecule is AB3L0, it's going to be trigonal planar. It's going to be trigonal planar, right? Perfect. If you look at the next one is SiCl4. I think SiCl4 we already discussed. This is AB4L0. AB4L0 means tetrahedral, right? You have got ASF5. 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 Tell me, how will it look like? ASF5. ASF5. Quick. This arsenic comes in nitrogen family, so 5 valence electrons. How many surrounding atoms? 5, so 5 sigma bonds. So that means there will be no lone pair on arsenic. So the type of the molecule will be AB5L0. AB5L0 means trigonal bipyramidal. So it is trigonal bipyramidal in nature, right? Then you have got H2S. H2S type is basically AB2L2 type, like water, so it's bent. PH3. PH3 will be like? PH3 will be like? Quick. It will be AB3L1 type. AB3L1 type means pyramidal. AB3L1 type means pyramidal. So this is how you check the shapes of all the molecules, right? Describe the change in hybridization, if any, of aluminum atom in the following reaction. So basically, you have got AlCl3 first. You have got AlCl3. You have got AlCl3. If I talk about its hybridization, since it's forming 3 sigma bonds, there will be no lone pair because aluminum has got 3 valence electrons and it is utilizing all the 3 valence electrons. So there is no lone pair, 3 sigma bonds, no lone pair. So if there is 3 sigma bonds, 0 lone pair, it's going to be sp2 type. Steric number is going to be 3. Steric number is going to be 3. Steric number 3 means sp2. Now you are giving one Cl negative to it. So what do we get? We get AlCl4 negative, right? So basically now what has happened exactly? A coordinate bond formation has taken place. A coordinate bond formation has taken place, right? Now coordinate bond is a type of covalent bond only. Perfect. So 1, 2, 3, 4. 4 sigma. 4 means steric number. Steric number is equal to 4. Steric number 4 means sp3 hybridization. So basically aluminum is going from sp2 to sp3. Aluminum is going from sp2 to sp3 here, right? Tell me the answer of this particular question. Considering x-axis as the internuclear axis. So imagine this is your x-axis, which I'm considering as the internuclear axis. X-axis I'm considering as the internuclear axis. Now, 1s and 1s. 1s and 1s. 1s and 1s. will do the head-on overlap. So it is going to form the sigma bond, right? Second one is 1s and 2px. This is s and this is px, right? Lobes along x-axis. So again head-on overlap. So this will be sigma bond. Perfect. 2py and 2py. If this was your x-axis, let this be py, let this be py. So py will do the parallel overlap. Parallel overlap leads to the formation of pi bond. Now 1s and 2s, right? Done. Again the axial overlap, I would say. Perfect. Is it clear? Is it clear, guys? I believe this sort of equation you can easily solve. Look at this one. Look at this one, guys. Describe the hybridization in case of PCl5. If you talk about PCl5, first of all, phosphorus. How many valence electrons? 5. How many surrounding atoms? 5. How many lone pairs? 0. What is the type of the molecule? AB5L0. What is the geometry predicted through hybridization, or what is the shape? It is trigonal bipyramidal. It's trigonal bipyramidal. So it's P. Let this be 1 chlorine. Let this be 1 more chlorine. Let this be 1 chlorine. 1 chlorine. So all these 4 atoms, phosphorus and 3 chlorine atoms, they are present on the same plane. Now perpendicular upwards there will be 1 chlorine. Perpendicular downwards there will be 1 more chlorine. Right? So this particular shape is what you call as trigonal bipyramidal shape. You call this particular shape as the trigonal bipyramidal shape. Correct? Now, my dear students, let me tell you, this particular bond and this particular bond, we call these bonds as the axial bonds. We call them as the axial bonds. And I would say this particular bond, this particular bond, this particular bond, which are present on the same plane, you call them as the equatorial bonds. You call them as the equatorial bonds. And axial bond length will be greater than that of equatorial bond length in case of AB5L0. In case of AB5L0, the axial bond length will be greater than that of equatorial bond length. Why is that? Because this chlorine has got the lone pairs, this has got lone pairs, this has got lone pairs, right? They'll be repelling this particular chlorine, due to which this bond length extends. Similarly, this particular bond length also extends due to the repulsions. Perfect. So axial bond length will be greater than that of equatorial bond length here in case of AB5L0 type. Okay. Can you tell me the answer of this particular question? What do you think about this one? What do you think about this one? Even this sort of equation you should be in a position to solve, guys. This sort of equation you should be in a position to solve. Quickly. Try it out at least. Try it out. Try it out. BF3 is planar and electron deficient compound. We already know that. Hybridization and the number of electrons around the central atom. So if I talk about BF3 first of all, if you talk about BF3, right? How many sigma bonds? 3 sigma bonds. So that means, you know, the type of the molecule is AB3L0. You know the steric number is 3 plus 0, 3. You know the hybridization is sp2. Now around the central atom, how many electrons do you see? 6 electrons. Right? You see 6 electrons around the central atom. Perfect. So it is done already. So it's sp2 and 6. Okay. Look at this one. Now again, this is the question which you should be in a position to solve. So you have to match one with, list 1 with list 2. PCl5. PCl5. What is the type of the molecule? It's AB5L0. SF6. Type of the molecule AB6L0. BRF5. Type of the molecule AB5L1. BF3. AB3L0. Now tell me the shapes, guys. It's simple. AB5L0 means trigonal bipyramidal. So A with 4. A with 4. A with 4. Okay. Then B with 3, B with 3. Let's not check B. C with 1, C with 2. Let's check C. This is AB5L1. AB5L1 means square pyramidal, right? AB5L1 means square pyramid. So C with 1. C you are going to match with 1. So it's going to be option A only. Right? Perfect. I believe this is also clear to everyone. In the structure ClF3, the number of lone pairs. Okay, ignore this table. Ignore this table here. This is by mistake here. It was a part of the last question. In the structure of ClF3, the number of lone pair of electrons on the central chlorine. Check it out. Check it out quickly, guys. Quickly. ClF3. If you talk about ClF3, chlorine is the central atom here. So 7 valence electrons. How many surrounding atoms do you see? 3 surrounding atoms. So 3 sigma bonds. So out of 7 valence electrons of chlorine, 3 valence electrons are utilized to form 3 sigma bonds. So there will be 4 electrons left as such in the form of 2 lone pairs. So there are 2 lone pairs on chlorine. There are basically 2 lone pairs on chlorine, which I was supposed to check. Right? Perfect. This sort of a question, you can easily kill, I believe so. Which of the following molecules represent the order of hybridization? sp2, sp3, sp, sp. sp2, sp3, sp and sp. Quick. Quickly, guys. So first of all, let me show you how to calculate the hybridization from the structure. See, guys. First of all, this carbon is forming how many sigma bonds? 1, 2. 2 sigma bonds means sp. This carbon is forming 1, 2. 2 sigma bonds, this also sp. This carbon is forming 1, 2. 2 sigma bonds, this also sp. This carbon is forming, again, 2 sigma bonds, this also sp. So sp, 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 sp everywhere. This is forming how many sigma bonds? 2 with hydrogen, 1 with carbon. So 2 plus 1, 3. So this sp2. This is 3 sigma bonds, again, sp2. 2 sigma bonds, sp, right? 2 sigma bonds, sp, right? So 4 sigma bonds, sp3. 1, 2, 3. 3 sigma bonds, sp2. 3 sigma bonds, sp2. 4 sigma bonds, sp3. Right? Similarly, 3 sigma bonds, this sp2. 3 sigma bonds, again sp2. 3 sigma bonds, again sp2. 3 sigma bonds, again sp2. Perfect. We have to check what? I think this should be sp2, sp2, sp, sp. This should be sp2 here. It should be sp2, sp2, sp, sp. From left to right, right? From left to right. Yeah. Okay. So that it's going to be sp2, sp2, sp and sp, right? So it's option number 2, which is going to be the correct answer of the question. Tell me the answer of this question. Again, simple and basic this is from the same chapter. Check it out. The species having the bond angle 120. Bond angle 120 means trigonal planar. Right? Trigonal planar. Which one is trigonal planar among all this? BCl3. Hybridization sp2. AB3L0. Bond angle is equal to 120 degree. Bond angle is equal to 120 degree. Check this one. Which of the following pair of compound is isoelectronic and isostructural? Isoelectronic and isostructural. How do you check the isostructural compounds? Just check the type of the molecules. If the type of the molecules is same, it's going to be isostructural. If the type of the molecule is same, it's going to be isostructural. If I select these two, we have got IBr2 negative and we have got XeF2 here. If I talk about this iodine, how many valence electrons it has? Iodine has got 7 valence electrons. There is negative charge, so 7 plus 1 makes it 8. 7 plus 1 makes it 8, right? Now, my dear students, how many sigma bonds do you see? 2 sigma bonds, right? Out of 8 valence electrons, 2 have been used. So there will be 6 electrons left as such on iodine in the form of 3 lone pairs. So 2 sigma bonds, 3 lone pairs. So it's going to be AB2L3. It's going to be AB2L3 type. Now talk about this XeF2. Xenon is the central atom. How many valence electrons? 8. How many sigma bonds? 2, right? Out of 8 valence electrons, 2 have been used. So there'll be 6 valence electrons left as such on xenon in the form of 3 lone pairs. So again, the type of the molecule is going to be AB2L3 only. If the type of the molecules is same, definitely the molecules are going to be isostructural. Okay? They are going to be isostructural. Perfect. Now this question, everyone knows The repulsion between lone pair is maximum, followed by lone pair, followed by bond pair. Okay. Check this one, guys. The hybridization of nitrogen in NO3 negative, NO2 positive, and NH4 positive. First of all, if you have got NO3 negative, nitrogen, how many valence electrons? 5. There is a negative charge, so 5 plus 1 makes it 6, right? How many surrounding atoms? 3. So sigma bonds 3. Now oxygen is divalent. Consider as if all the oxygens have formed double bonds, right? So out of 6 valence electrons, all the 6 would have got exhausted, right? As per the rule which I'm showing you. So there will be no lone pair on nitrogen. So the type of the molecule will be AB3L0. Steric number is going to be, steric number is sigma plus lone pair, 3 plus 0, 3. Hybridization will be sp2. Okay. NO2 positive. Nitrogen should have 5 valence electrons, but there is positive. 5 minus 1 makes it 4. How many sigma bonds? 2 sigma bonds, right? So since oxygen is divalent, so I would say all the 4 valence electrons of nitrogen would have utilized. So there will be 0 lone pairs. So steric number will be 2 plus 0, 2, right? The type of the molecule is going to be AB2L0. And if it is AB2L0, it's supposed to be linear. We don't have to talk about the shape though. So this AB2L0, we have to check the hybridization only. Hybridization will be, if steric number is 2, it's going to be sp hybridized. Now NH4 positive, everyone would be already knowing it's sp3 hybridized, right? So it's sp2, sp, sp3. sp2, sp, sp3. So it's option 3. That will be the correct answer of this question. Okay. Sriram was asking about chemical bonding part 2. Chemical bonding part 2 would already have been posted. Check the video section. Check the video section. I had scheduled it for 4 p.m. Check if it is posted or not. Go to the video section once. Is it posted already? Just a second, guys. Just a second. I have scheduled it for 5 p.m. not 4 p.m. Sorry. It is scheduled at 5 p.m. It is scheduled at 5 p.m. Huh? Okay. It is scheduled at 5 p.m. How to remember the bond order? There's a trick for bond order calculation as well, which I'll tell you in some time. Just wait for it. Okay. Look at this question, guys. Maximum bond angle at nitrogen is present in which of the following compounds? First of all, maximum bond angle can be 180. 180 is present in sp. Maximum bond angle is 180 degree, and 180 degree is present in sp. Sp means the steric number is 3. Sorry, the steric number is 2. Right? The type of the molecule is AB2L0. Now check the types of the molecules. So NO2 positive. Few minutes back only we saw its hybridization is sp. So its bond angle has to be what? Its bond angle has to be 180 degree. Yeah. Tell me the answer of this question. Which of the following species contains 3 bond pairs and 1 lone pair? 3 bond pairs and 1 lone pair. So that means the type is AB3L1. 3 bond pairs and 1 lone pair. Check all of them. I believe it's going to be PCl3. Phosphorus, how many valence electrons? 5. How many surrounding atoms? 3. So 3 sigma bonds. Out of 5, 3 have been used. So 2 will be left as such on phosphorus in the form of a lone pair. So 1 lone pair. So 3 sigma bonds, 1 lone pair. Right? 3 bond pairs and 1 lone pair. So it's going to be PCl3 only. Yeah? Correctly done? Check this one out. In which of the following pairs both the species have got sp3 hybridization? sp3. See, sulfur has got 2 lone pairs here. Boron has no lone pair. Steric number of this sulfur is 2 sigma bonds, 2 lone pairs. So steric number is 2 plus 2, 4. So it's sp3. And boron is forming just 3 sigma bonds, no lone pair. So it's sp2. Right? This is sp3. This is sp. Nitrogen has got 1 lone pair. Oxygen has got 2 lone pairs. So 3 sigma bonds, 1 lone pair. Steric number 4. So it's sp3. 2 sigma bonds, 2 lone pairs. So it's again sp3. Right? NF3. It's sp3. PF3. sp2. So we were supposed to check sp3, right? So it's going to be NF3 and water. Again, a simple basic question only. Okay. Tell me the answer of this one. Tell me the answer of this particular question, guys, quick. Everyone. Pyramidal shape. Pyramidal shape means AB3L1 type. Now, which of the following is AB3L1? You can directly see it's PF3, which is AB3L1. AB3L1 means pyramidal shape. Yeah? Perfectly done. J means 2023. I have 7 molecule. Number of lone pair of electrons on the central atom. In case of this particular iodine, there will be no lone pair on iodine because iodine has got 7 valence electrons and all the 7 valence electrons have been utilized to form 7 sigma bonds. So no lone pair on iodine, right? ICl4 negative. Again, no lone pair on, how many? See, if I talk about ICl4 negative, iodine has got how many valence electrons? 7 plus 1 makes it 8. How many sigma bonds? 4 sigma bonds. Out of 8, 4 valence electrons have been utilized. So 4 are left as such in the form of 2 lone pairs, right? So there are 2 lone pairs on this iodine. XCF6, there is 1 lone pair. XCF2, there are 3 lone pairs, right? Now you can just match them. So IF7 you are going to match with 4. A with 4, okay? A with 4. B with 3. Yes, B with 3, right? C with, it is directly option 2. It's directly option 2, guys. Yeah? This is again the question that has been asked in JEE Mains 2023. Can you check this out? What should be the answer of this question? Check this out too. First of all, XCF4. If you look at the type of the molecule, it will be AB4L2 type. Right? SF4 would be AB4L1 type. NH4 positive would be AB4L0 type. BRF3 would be AB3L2 type. Now, check their shapes. AB4L2 means square planar. It is square plane. The AB4L1 means seesaw shaped. AB4L0 means tetrahedral shapes. AB3L2 means T-shaped. Now you can match. Now it becomes easy. Now it is easier for everyone, right? It's easier for everyone. I think this question already we solved. Yes, this question we have solved. Okay. Look at this one. The ion that has sp3d2 hybridization for the central atom. Where do you see the central atom has got sp3d2 hybridization? sp3d2. My dear students, if I look at all the options, for example, if I select this option, ICl4 negative. Iodine has got how many valence electrons? 7. There is a negative charge, so 7 plus 1 makes it 8. How many surrounding atoms? 4. That means there will be 4 sigma bonds. Out of 8 valence electrons, 4 valence electrons have been utilized to form 4 sigma bonds. There are 2 valence electrons left as such on iodine in the form of 2 lone pairs. So 4 sigma bonds, 2 lone pairs. The type of the molecule will be AB4L2, right? Steric number is 4 plus 2, 6. If steric number is 6, hybridization would be definitely sp3d2 here, right? So it's going to be option 3. That would be the correct answer of this one. Yeah? What about this one? The sum of the number of lone pair of electrons present on the central atom. We have got XCO3 first. XCO3. Xenon is the central atom, so 8 valence electrons. How many surrounding atoms? 3. Right? But oxygen is divalent, so 3 2s are 6. Out of 8, 6 are utilized. 2 will be left as such on xenon. So 1 lone pair on this xenon. What about this one? Again, 1 lone pair will be left on this particular xenon. Right? What about this one? Again, 1 lone pair will be left on this particular xenon. So the sum of lone pairs will be 1 plus 1 plus 1 makes it 3. So there are in total 3 lone pairs here. Okay? What about this one? The number of species having non-pyramidal shape. Non-pyramidal shape, guys. What do you think about this one? So basically, you have to check those compounds which do not have the pyramidal shape. So pyramidal shape will be in AB3L1 type. This is pyramidal. So whatever species is apart from AB3L1, that is non-pyramidal. So SO3 is definitely AB3L1 type. NO3 negative. NO3 negative is AB3L0 type. PCl3 is AB3L1 type. CO3 di-negative. CO3 di-negative. It is AB3L0 type. Can you check them? We have to check the species which are non-pyramidal. Non-pyramidal will be this one, right? AB3L0. Even this one. This is pyramidal. This is pyramidal. Perfect. So 2. Answer is going to be 2. This is the question which we have already done. Okay. Tell me the answer of this one. I just want to know. What do you think about this one? In case of D2sp3, which d orbitals are involved in hybridization? It is going to be dx square minus y square and dz square. Remember this directly. Dx square minus y square and dz square. These are the orbitals which are involved in D2sp3 hybridization. If they ask you about sp3d hybridization, which d orbital is involved? Remember it's dz square. If they ask about sp3d3 hybridization, which d orbitals are involved? It is dx square minus y square. Similarly, it is dz square and it's dxy. Okay, anything can be asked out of these. And this sort of a question you can easily solve if it comes. Now, for example, this is the question. ASF5, right? So first of all, if you look at the hybridization, valence electrons in arsenic are 5. There are 5 sigma bonds, so there is no lone pair. That means the steric number is 5 plus 0, 5. Hybridization is sp3d. If hybridization is sp3d, so which orbitals are involved? It is s, px, py, pz and dz square. Right? S, px, py, pz and dz square. S, px, py, pz and dz square. So it's option C. Okay? Yes, SO3 is planar. Did I write it non-planar? SO3, just a second. Where was SO3? Oh, we did a mistake here. Sorry. We did a mistake here. This is SO3. It is basically divalent, so it's AB3L0. This AB3L0. Okay. This one, let's check again. This is AB3L0. This AB3L1. This is AB3L0. Okay. The number of species which are non-pyramidal. Non-pyramidal is only 1. So the answer of this question is 1. Okay. See, this is planar, this is planar, this is planar, and this one is only pyramidal. So we were supposed to check the species having non-pyramidal shape. Non-pyramidal means 1, 2, 3. So 3 are non-pyramidal. This one is pyramidal. So answer is 3. Can you tell me the answer of this one quick? Quickly. What do you think about this one? The correct geometry in hybridization in case of XCF4. In case of XCF4, it's going to be AB4L2 type. AB4L2 means hybridization will be sp3d2, right? Because the steric number is 4 plus 2, 6, right? And sp3d2, AB4L2. AB4L2 means square planar. It is square planar, right? So this is the answer. Square planar and sp3d2. Tell me the answer of this one. In water, since the hybridization is sp3, so bond angle should be 109 degree, 28 minutes. But the actual bond angle is 104 degree, 5 minutes. What is the reason? The reason is the repulsions. Between what? Lone pair repulsions. In case of water, because of the lone pair repulsions, the bond angle which was supposed to be 109 degree, 28 minutes, that is not 109 degree, 28 minutes, that's 104 degree, 5 minutes. Okay. What about this one? Select the correct statement regarding PCl5, BRF5 and IF7. See, first of all, if you talk about PCl5, PCl5 means AB5L0. AB5L0 means trigonal bipyramidal. BRF5, it is AB5L1. AB5L1 means square pyramidal. Square pyramid. IF7 means AB7L0. This will be pentagonal bipyramid. Select the correct statement regarding the following. All are square pyramidal. No, all are not. All are trigonal bipyramidal. No. One of the given compound is square pyramidal. Yes, one is given. I mean, one is the square pyramidal. One is tetrahedral. There is no tetrahedral. It's option C. Correct? This is also clear, I believe. Hello. Tell me the answer of this particular question in the chats, in the comment section, I mean. And this was our last question of the today's session. I hope all this stuff, whatever questions I've given you, I think all the questions are like very clear to everyone. Okay. Chalo guys. I'll see you with the next session, right? Till then, you can take care. God bless you and love you all.